Hello viewers, this is Dhanjit and welcome to my YouTube channel Reaction Concept. Guys, जैसे कि पूरे देश पे ही क्या चल रहा है, लॉकडाउन चल रहा है, तो most of the states have decided that their class 11 exam will be cancelled out. Okay, as a result, you will be already promoted to class 12. So because of lockdown, the classes of class 12 is not started yet. So in this channel, we started to deliver the classes of class 12. I will here discuss about the chemistry. Okay, first in this video I'll discuss about solution chapter of physical chemistry. So without any further delay, let us start the video. So viewers, we'll start from a physical chemistry chapter, that is solution. Okay, first we will discuss some very basics of solutions of these solutions, then we'll go for some problem in this video. Okay, so what is solution? So if you see what is solution, then it is a homogeneous mixture of two components. Solution is a homogeneous mixture of two components. Okay, so if you suppose a component is A and other one is B, okay, the component which is present in less amount in a solution is known as solute. Okay, and the component which is present in larger amount, it is known as solvent. So you can define solution as a homogeneous mixture of two components, and the component which is present in less amount in the solution is known as solute, and the component which is present in larger amount is known as solvent. Okay, for example, you see, if you dissolve 2 grams of sugar in a 100 ml of water, in this case this will make a sugar solution, aqueous solution of sugar, where sugar is the solute and this will be the solvent of the solution. But there are some exceptions also. Okay, when you see, in this case the solute is present in solid state, it is present in liquid state. So in this case it is very easy to distinguish the solvent and solute. But you see, in case of solution like this, 20 ml of ethanol and 20 ml of methanol is mixed, then which one will be the solute and which one will be the solvent? Suppose you are given here the cryoscopic constant of methanol and cryoscopic constant of ebullioscopic constant of ethanol is given. Here in this case the Van't-Hoff factor of methanol is given, that is I. These things will be discussed later on this chapter. Okay, so don't worry about these terms: cryoscopic constant, ebullioscopic constant, Van't-Hoff factor. Okay, these things will be discussed. Then the component with respect to which these constants are given can be considered as solvent, and this can be considered as solute of the solution. Okay, this is how you can distinguish in a mixture which one is solute and which one is solvent. Now we'll discuss about some concentrations, okay, of solution. So what is concentration? Before going to this, you should know what is concentration of a solution. So it is the amount of concentration is the amount of solute in a known amount of solvent or solution. That is, for a fixed amount of solution, what is the amount of solute? That is termed as concentration of the solution. This concentration is expressed in terms of various factors. Okay, in various expression, concentration can be expressed. For example, you can express as percentage unit, in terms of molarity, in terms of normality, molality. These are the expressions of concentration. We'll discuss all these concentration terms one by one. Okay, so before going to the different concentrations term, we should know some basics of mole concept and equivalent concepts. Okay, some terms you should know. So what are the basics of some basics formulas you should know? These are: number one, number of mole. These are already discussed in class 11, some basic concepts of chemistry in the mole concept, that chapter. In that chapter it is already discussed. Number of moles of a substance is equal to the given weight of the substance divided by gram molecular mass of the substance. Similarly, number of equivalent of a substance, it is the given weight divided by gram equivalent mass of a substance. This gram equivalent mass can be expressed as, again it can be expressed as gram molecular mass divided by valence factor. So number of equivalent, it is denoted by N, it is denoted by NEQ. Okay, so number of equivalent equal to the given weight of a substance divided by gram molecular mass into valence factor. This is valence factor. So this will be equal to number of moles of the substance into valence factor. So number of equivalent can be written as number of moles into valence factor of the substance. Equivalent mass of a substance is equal to the molecular weight or gram molecular weight of the substance divided by valence factor for a compound. Okay, similarly equivalent mass of an element can be written as atomic weight divided by valence factor of the element. Okay, these four things you should know before starting the concentration expression of solution. Now we will discuss the different concentration expression. Different concentration units will be discussed here for solution. Number one is the percentage unit. 4 percentage units are there, and these are percentage of W by V. It is also known as by volume concentration or by volume. Okay, this can be called as by volume. So it is the amount of solute, it is the amount of solute in a solution in terms of gram when the amount of solution is 100 ml. Okay, so percentage W by V, this percentage unit can be described as it is the amount of solute in terms of gram present in a 100 ml of solution. That is known as percentage W by V or by volume concentration of a solution. Similarly, you have two other percentage unit, and these are, for example, you can take as, suppose you have a solution given 2% of W by V sodium hydroxide solution. Okay, this means 100 ml of solution of sodium hydroxide will contain 2 gram of sodium hydroxide. Therefore, 200 ml of solution will contain 4 gram of sodium hydroxide. Okay, this is how percentage units are expressed. There are other two percentage units are there. So these are W by W or by weight concentration. Okay, so these can be described as, this is the amount of solute in terms of gram when the amount of solution is 100 gram. So W by W percentage can be defined as the amount of solution in terms of gram present in 100 gram of a solution. That is known as percentage W by W concentration of a solution. Another concentration term are there, that is V by V or by strength. This is also known as by strength. So by strength, it is the amount of solute in ml, expressed in terms of ml, in a solution of 100 ml volume. Okay, so in a solution of 100 ml solution, if you express this solute in terms of ml, that concentration is known as V by V or by strength concentration of a solution. Okay, now we'll discuss about number 2 concentration unit of a solution, that is gram per liter. You may also come across this concentration term, gram per liter. So this can be described as, it is the amount of solute present in terms of gram per 1 liter of a solution when solution is 1 liter or 100,000 ml, 1 liter. Okay, this concentration term is known as gram per liter. Third one is molarity. It is denoted by capital M. So molarity, it is the amount of solute in terms of mole, that is number of moles in a solution of volume 1 liter. That is known as molarity of the solution. Number 4, it is normality. So it is the amount of solute in terms of number of equivalent in a solution of volume 1 liter. So this is the normality definition. Number 5, it is molality. This is something peculiar. Okay, so it is the amount of solute which is expressed in terms of moles. Here the solute is expressed in terms of mole, where amount of solvent is 1000 gram. Okay, so molality can be defined as it is the amount of solute in terms of mole, or number of moles of solute in a 1000 gram of solvent is known as molality. Okay, you can define also this way. So number 6, it is mole fraction. We have already discussed, we have already mentioned that solution is composed of two types, two components. One is solute, another one is solvent. Okay, consider the number of moles of solute is Na and number of moles of solvent is Nb. Then mole fraction of solute can be expressed as the ratio of number of moles of solute divided by total number of moles of solute and solvent. Similarly, the mole fraction of solvent can be written as number of moles of solvent present in the solution divided by total number of moles of this solution. Okay, so summation of these two values will be solute plus solvent is always equal to 1. This you should remember. Next, number 7, concentration term. This is ppm, parts per million unit, also written as ppm unit. So this type of concentration unit is generally used for very dilute solution, where amount of solute is very less. Okay, for very dilute solution we can use this kind of concentration term. So let us see the definition of such concentration term. So it is the amount of solute in gram when amount of solution is 10 to the power 6 gram, that is 1 million gram. It can also be expressed as amount of solute in ml when solution is 10 to the power 6 ml. Okay, it is, sorry, it would be ml. So this is the parts per million. Another concentration term is there. This would be the last, volume strength. This kind of concentration unit is generally used for aqueous solution of, these are used for, aqueous solution of hydrogen peroxide solution. Okay, this is also known as stock solution. Generally, the solution of stock solution, this stock solution, generally this is called as stock solution, generally decompose this hydrogen peroxide, decompose to water and oxygen. Okay, so when 1 ml of hydrogen peroxide is decomposed and give water and oxygen, then amount of oxygen produced in terms of ml is known as volume strength of a stock solution. Suppose you are given a stock solution where volume strength is given 20 ml. Suppose you have a solution where volume strength is given as 20 ml. Okay, what does it mean? It means that a solution of hydrogen peroxide is given, which solution on decomposition of 1 ml of such solution will give you 20 ml of oxygen at STP condition. Okay, provided STP condition is there, standard temperature and pressure considered. Standard temperature and pressure conditions will be there. Okay, so these are the 8 concentration terms for a solution. So you should note all these terms. Now we'll see some problems or numericals based on these formulas that I have discussed. Okay. Okay guys, that's it from today's video. If you have any doubt, you can ask me in the comment section below, and if you have liked this video, then give a big thumbs up for this video and share this video with your friends during this lockdown so that he will be also beneficial. And if you are new to the channel, then subscribe our channel and don't forget to press the bell icon for further notification from this channel. I'll see you in the next video.